Hello friends, in this video we are going to see the topic process synchronization tools. Under that mutex logs and the monitors under the subject CS3451 Introduction to Operating Systems. This is Satish Pandian, Assistant Professor, Department of CSC, Government College of Engineering, Bodinaikanur. So first we saw the topic mutex logs. So before seeing this, just I will tell an example. So we have 50 students in our class. We are going to provide a cake for all. The cake in the next room, there are 50 pieces of cake. If we allow all the students to take cakes, what will happen? Surely 15 to 20 students will not get, because some will take 2 or 3. Some cakes will fall down. So everyone will not get cakes. So in this situation, we can use this topic, mutex logs. So here, how this will be provided means, suppose first students going to enter a room to get cake. What he or she will do after entering into the room, he just lock the door. If he locks the door, then no other person can enter into the room. So only one person is now inside the room. He can take the cake and eat. After that, go out after opening the lock. So while entering the room, he is locking the door. After eating the cake, while going out, he is opening the door. That is releasing the lock. Once lock is released, now door is open. Second student can come. So once the next student enters, he also put the lock so that others cannot enter and go like that. So synchronization is provided. Same thing is used here. So mutex logs are nothing but a high-level software tools. We can solve the critical section problem. Here, log is used to protect critical sections. So here, critical section is nothing but that a cake inside the room. That is critical section. Okay. That is, a process must secure the log before entering a critical section. Suppose a process want to enter into critical section, it has to get the log. Then it releases the log when it comes out of the critical section. So if a process releases the log, then only other process can enters into critical section. Okay. For acquiring and releasing the log, two methods are used. They are called acquire and release. The mutex log has a Boolean variable which is called available. Boolean means either it have true or false value or 0 or 1 value. Okay. If the log is available, call to acquire succeeds. That is, if the available value is true, then a process can enter into critical section by calling acquire log. After acquire log, the available value will be changed as false, so that some other process cannot be entered into critical section. After completing the critical section, process can call release method. At the time, again the available value becomes true. Okay, so that things will be given. Whenever a process wants to enter into critical section, it has to get locked. For that, acquire method will be called. After completing the critical section, while come out, a process can execute a release lock method. Okay. Both methods, acquire and release, will use available variable. This is called available variables used here. So during acquire, we are checking whether the variable is available or not. If it is true, process can enter into critical section and make this as false. Similarly, in the release method, already it is false. It can be changed as true so that the next process can enter into critical section. So this is called mutex logs. Okay. So here another definition related to that, logs are either contented or uncontented. Okay. A log is considered as contented if a thread blocks while trying to acquire the log. That means some other process already using the log already in the critical section. So current process cannot be entered. In this case, the lock is considered as contented. Okay. If a lock is available when a thread attempts to acquire it, the lock is considered uncontented. That means now the lock is free. A process trying to enter into critical section, so it can now acquire the lock. At that time, it is called uncontented. Okay. So here the main advantage is the busy waiting will be avoided. Okay. This is the advantage of mutex locks. The next topic is monitor. So monitor, again, it's a high-level synchronization tool. It is used for process synchronization. So before that, why we are going for a monitor, that we will see. So without a monitor, normal simple tool for process synchronization is semaphore. We already discussed in the previous video. So semaphore have some drawbacks. This is a drawback of semaphore. So normally we will use the wait and signal in this order. Before critical section wait, after critical section signal. But if we interchange wait and signal, what happens means violates the critical section problem. That is, more than one process may enter into critical section. That's a problem. And normally we have to give wait and signal. But above and below the critical section, if you use only wait operations, here no process will be allowed to enter into critical section. Everything will be in the waiting state. Similarly, if you omit either wait or signal, again the problem comes. So to overcome these problems, this monitor is used. Okay, so it's a high-level synchronization construct that is using programming language. We have to implement this monitor. It contains three things: variable declarations, a set of procedure definition. That means functions and some initialization code. So that is given here. This is variable declaration, set of procedures, and the initialization code. This is the structure of monitor. So everything is given here in the diagrammatic representation. This is a data, set of data or variables, set of procedures, and here we have data now. For that, initialization code is given. Okay. What are the processes going to access this monitor? They will be placed in the queue. Okay. Here, processes are placed in the queue. They will be allowed one by one to enter into monitor. So at a time, one process allowed to enter into monitor to access the common data or procedures. Okay, so that is given here. Again, in addition to monitor, another synchronization construct is used, that is called the condition construct, or it is called the condition variables. We can create condition variables like this: condition x comma y. Here x and y are condition variables. Again, this variables can access wait and signal operation, x dot wait, x dot signal, like that. Okay. If a process executes wait like this, x dot wait, what is the meaning? Means that process will be suspended from executed. So execution, if any process executes wait, it will be suspended or immediately stopped from the execution. Similarly, if any process executes signal, then it resumes exactly one suspended process. So whenever we are executing signal, already some waiting process will be there. From that, any one process will start to execute again. Okay. So this is again same kind of diagram with the condition variables. So here we have condition variables x and y. So these are the process with respect to condition variable x. Here we have list of process with respect to y. Okay. So this monitor topic. So that's all about mutex logs and monitor. So these are used for process synchronization. Thank you.